Hello, Mr. Claudia here, and today we are going to continue learning the derivative rules. Now, so far we've gotten to know the easy derivative rules, and we understand what the derivative is. Now we have to spend a few lessons looking at more difficult derivatives. So, the one that we're going to be looking at today allows us to take the derivative of a function multiplied by a function. Now, you might look at this as a bracket and a bracket, but consider we can take the derivative of that on its own. We can take the derivative of that on its own. How do I take the derivative of when they're multiplied together? Let's see if we can figure this out. So let's say we have f of x is equal to g times h. G is this function, h is this function. The tendency might be just, oh, let me take the derivative of the first one multiplied by the derivative of the second one. And let's see what that looks like. So first of all, okay, so we have f of x is equal to 3x squared plus 2 times 1 minus 2x squared. My actual solution, the best way to find it would be to expand. So let me expand by foiling. So I get 3x squared minus 6x4 plus 2 minus 4x squared. I can clean this up a little bit. So I end up with, for some reason I put it this way, but I have, okay, so negative x squared minus 6x4 plus 2. Okay, so that's my function. So now I know this is definitely the same as this. Let's find the derivative, which is negative 2x minus, okay, I should be getting good at this now, 6 times 4, 24x to the 3, and the 2 I don't see. So that is the derivative. That is absolutely 100% a correct derivative. But it's a lot of work because I had to FOIL. I had to do that expanding. Okay, so let's try this shortcut. Instead of expanding, let's try g prime at x times h prime at x. So g prime at x is derivative, okay, so it'd be 6x. And h prime at x is going to be negative 4x. And so if I were to multiply those derivatives together, I would get 6x times negative 4x, which is negative 24x squared. So I know it's a little kind of roundabout what we're showing here, but I'm saying, hey, if I give you a function like this, couldn't I just take the derivative of the first thing, multiply it by the derivative of the second thing? Well, when I do that, which I did here, I get negative 24x squared. That's not correct, because I know this is correct. I FOILed, and then I took the derivative of the expanded form. So this is wrong. So this is my proof that the derivative of f in this case does not equal the derivative of the first thing times the derivative of the second thing. A lot of the things we've seen so far, the rules for limits and derivatives, they follow what we know. They seem pretty logical. This is where we deviate from that. The product of two functions, we have to find a derivative, we have to use the product rule. That is, you hear this, derivative of f is equal to the derivative of g times h plus g times the derivative of h. Let's just think about this in words before we go on and do some examples. Some of you will prefer the examples, some of you will prefer the definition. But think about what this is saying. The derivative of a product is the derivative of the first function times the second function plus the first function times derivative of the second function. Seems like a lot of work. It's not so bad once we start doing questions. And it's, confusing to learn in the form that we give you, but you'll find soon that this is just a process that we're teaching you. Let's try doing this example. So y equals this function times this function. It's a product of two functions. Again, you could FOIL it. FOILing is a lot of work. Instead, I'm going to recognize that this is my first function, and this is my second function. So let's apply the product rule. Y prime is equal to, I'm just going to write out the instructions. So this means take the derivative of the first function, 5x minus 3. So take the derivative of that, multiply it by the second function, plus the first function, which is 5x minus 3, times, once again, the derivative, but this time of the second function. Ooh, okay, so now I have some instructions. Now let me figure this out. What's the derivative of the first function? Well, it's just 5. I'm going to leave the x squared plus 4x minus 3 as is, plus 5x minus 3. And what's the derivative of the second function? That's 2x plus 4. Okay, now my calculus is done, right? I've done all the derivatives. Now I just need to clean up my algebra, collect like terms. This 5 gets distributed, and here we're going to FOIL, right? We're going to expand this. So I end up with 5x squared plus 20x minus 15 plus 10x squared plus 20x minus 6x minus 12. Okay, and now I can collect my like terms. So okay, so I get 15x squared, 20 is 40, so I get 34x, and minus 27. So there you have it. It's not so difficult, it's just a process we have to get used to. Didn't really do great space here. What if I wanted to find the derivative of this function at x equals 1? Well, then I would sub in 1. And I wanted to do this to show you some notation. (15 plus 34 is 39, 49, subtract 27 is 22. I just wanted to show you when you're subbing in and you're not using the F notation, you're using y prime or dy dx, you can actually, you just put this vertical line and you put x equals 1. That's showing me that I'm subbing x equals 1 into this function, or into this equation, and then we get our answer, 22. That's the slope of this function at x equals 1. Excuse me. Let's turn in the page. Oh wow, what a short lesson. Jeez. This is too good to be true. Okay, let's practice. Again, you might want to pause here, try doing this on your own, but if you do, you come back and check your answer. So, this is a function times a function. If it helps, and maybe it will help you, some of you guys do this all the way to the end, right? First and second, so you don't forget. This is a product rule situation. So let's write dy dx is equal to the derivative of the first thing times the second thing plus the first thing times the derivative of the second thing. Okay, now what's the derivative of 2e to the x? Well, that's an easy one. It's just 2e to the x. Don't be tricked, right? E to the x, very quick. And then we leave this. And then we have 2e to the x. What's the derivative of this expression? It's 2x minus 5. Now, I got to clean this up. What I see when I do this question is I see a common factor, 2e to the x. So I'm going to factor that out. Remember, factoring means you divide each term by the common factor. So my common factor is 2e to the x. So I'm going to divide this whole thing by 2e to the x, so I'm left with x squared minus 5x plus, when I factor out 2e to the x, I'm left...
Hello, Mr. Kaladi here, and today we are going to start
Okay, just finished compiling a video. 2x minus 5. So now I can just collect my like terms in the bracket there, and I get x squared minus 3x minus 5. So that's our derivative. And this is common when you have an e to the x. There is often a common e to the x factor for a product rule involving e to the x. So this is something you might see this kind of pattern when you have an e to the x question, because the e to the x keeps getting the derivative, but it doesn't change. So you find it in both terms. Let's do one more question. That's an ugly question. First, second. In fact, I'm going to write it out though, because I don't like the square root sign. This is going to be x to the half, and this is going to be 2 minus 3x. And again, you can write this as first and second. Okay, here we go. So, derivative is... Now, you don't need to write out this line every time, the instruction line. I mean, it's helpful. It's not wrong, and it tells you what to do and make sure you don't make a mistake. But once you've done enough of these, you can just go through the process. So here we go. The derivative of a product of two functions is, product rule, the derivative of the first function times the second function plus the first function times the derivative of the second function. Hopefully you're getting good at doing derivatives. Okay, now we need to distribute this whole thing here like this. So I end up with half times, okay, so I get 2 over 2 x to the negative half minus 3 over 2 x to the negative half times x to the 1 minus 3x to the half. Okay, so now I end up with, okay, the 2 over 2 is just x to the negative half. This becomes negative 3 over 2 x to the negative half plus 2 over 2 minus 3x to the half. Oh my god, you can't see anything. Just a little bit of algebra here, right? It's a little bit of an algebra pain. Okay, so this is x to the negative half minus 3 over 2 x to the half minus 3x to the half. Okay, then I have to collect these like terms, so get x to the negative half minus 3 over 2 x to the half minus 6 over 2 x to the half. So I'm trying to like make it so I can combine these like terms. So now, I end up with x to the negative half minus 9 over 2 x to the half, and just for good form, this is going to write this properly, 1 over root x minus 9 over 2 root x. Okay, and again, you can't see anything. Okay, so again, the calculus is actually just this line, right? The first line, that's the only calculus you're doing. The rest is just algebra, which you've been doing all your life, but you finally get a nice simplified expression. Now note, for this question, it would have been easier to expand the original function to f at x is equal to 2x to the half minus 3x to the 3 over 2, and then differentiate using the power rule. So that is, sometimes it is best to avoid the product rule. So, just, you can see that the product rule here made our life more miserable. It was a little harder. Sometimes it's worth simplifying the function and then applying just the power rule, which is a lot easier. So, something to consider. And you'll see that, I believe in your homework, there's a few questions where you have to be aware of that. So, your homework for today is page 212, number 2, 4, 7, and 9, and page 214, number 2, 3, 5, 8, 10, 12, 13, and 14. Why is this so complicated? Because tomorrow we're going to learn the quotient rule, and the homework is mixed of the two of them together. So today you're just doing the questions that have to do with the product rule. Stay tuned next time for the quotient rule. We'll see you then. Bye-bye.